Question 1. A liquid is poured on a flat surface forming a circular plot. The radius of the plot of liquid increases at a constant rate of 6 cm per second. Increases at a rate of 6 cm per second. Find the rate at which the area is increasing when the radius is 8 cm. So we have dr, where r is the radius, over dt. We are given dr dt being 6 cm per second. This is the rate at which the radius is increasing while we are pouring. And we are finding dA by dt, where A stands for the areas. So we'll find the rate the area is increasing. We know that area of circle has a formula A equal pi r squared. To find the rate of the area is increasing, we take the derivative dA over dr. Since r here is the only variable, so we have pi, and we differentiate r squared is 2r. Now we can make use of chain rule. We use a chain rule where dA by dt, rate of increase of the area, equal rate of increase of area with respect to the radius, and multiply by dr over dt. So we know that dA over dr is 2 pi r, whereas dr over dt is given as 6 cm per second, multiplied by 6. So we have 12 pi r. Now, when the radius is 8 cm, when r equal to 8 cm, we have the rate of increase of the area with respect to time equal 12 pi, where r is 8 cm, so becomes 96 pi. Area is cm squared, so cm squared. The rate divided by seconds. So this is the rate at which the area is increasing when radius is 8 cm. Question 2. A liquid is poured on a flat surface forming a circular block. The radius of the block of liquid increases at a constant rate of 6 cm per second, increasing at a rate of 6 cm per second while the liquid is poured. Find the rate at which the area is increasing when the area is 25 pi cm squared. We are given dr over dt, where r is the radius of the plot, being 6 cm per second. This is the rate the radius is increasing while the liquid is poured. We are finding the rate at which the area is increasing. So we are finding dA, where A is the area of the circle, dt. We know the area of circle has a formula A equal pi r squared. Now we are given area of circles being 25 pi, which means that r squared equal 25 pi over pi, which is 25. And so we have radius r equals square root of 25 being 5 cm. Okay. From the area A equal pi r squared, we get dA over dr being pi, differentiate r squared is 2r, so it's 2 pi r. Now we use chain rule. We want to find dA over dt. We express it as dA over dr multiplied by dr over dt, which is dA over dr is 2 pi r, 2 pi r, and dr over dt is given as 6 cm per second. Okay, 6. So we have 6 times 2 is 12, 12 pi r. Now, when area is 25 pi cm squared, we know that r is 5 cm. So, dA over dt is 12 pi r, where r is 5 cm. We have 12 times 5 is 60, so we have 60 pi cm square per second. This is the rate at which the area is increasing when the area is 25 pi cm square. Question 3. A liquid is poured on a flat surface forming a circular block. The radius of the block of liquid increases at a constant rate of 6 cm per second. Find the rate at which the area is increasing when the circumference is 8 pi cm. So this radius is increasing when the liquid is poured. We are given dr over dt, where r is the radius, as 6 cm per second, and we are also given the circumference c being 8 pi cm. We are finding the area of increasing, meaning we are finding dA over dt when the circumference is 8 pi cm. We know that the formula of circumference, circumference, circumference of circle, c equal 8 pi cm, and the formula is 2 pi r. So we have r equal 8 pi over 2 pi, which is 4 cm. An area of circle has a formula A equal pi r squared. And so the rate of area increasing with respect to r equal pi differentiate dr squared over dr equal pi 2r, which is 2 pi r. Now we use chain rule. dA over dt equal dA over dr multiplied by dr over dt, which is dA over dr is 2 pi r, and dr over dt is 6. So we have 12 pi r. So when the circumference C equal 8 pi cm, we have radius r equal 4 cm. And so dA over dt, the rate of increasing of area with respect to time, equal 12 pi r, where r is 4 cm. So we have 48 pi cm square per second. Question 4. A liquid is poured on a flat surface forming a circular pot. The radius of the pot of liquid increases at a constant rate of 6 cm per second. Find the rate at which the area is increasing when t equals 3 seconds and the initial radius is 2 cm. So we are given dr over dt, where r is the radius of the circular pot, as 6 cm per second. And when t is 3 seconds, we are going to find the rate of area increasing, dA over dt. And we are given initial radius being 2 cm. First, we find the radius at t equal 3 seconds. So the radius r equal initial radius plus the rate of radius increasing multiplied by t, or we call it dt at 3 seconds. So we have r equal 2 cm plus dr over dt is 6 cm per second. And we multiply by 3 seconds. So we have 3 times 6, 18 plus 2, 20 cm. 20 cm. Meaning that with initial radius of 2 cm and the rate of dr dt equals 6 cm per second, after 3 seconds later, the radius becomes 20 cm. And we know that area of circle has a formula A equal pi r squared. And so we take the derivative with respect to r. dA over dr will be 2 pi r. Now we use chain rule. We express dA over dt equal dA over dr multiplied by dr over dt, which is dA over dr is 2 pi r, and dr over dt is 6, so is 12 pi r. And so when r equal to 20 cm, this is when t equal to 3 cm. And we have dA over dt being 12 pi r, where r is 20 cm. So we have 12 times 20 is 240 pi cm square per second. Thank you for watching. If you like this video, please press like, subscribe, and turn on all notifications. Thank you.